Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to my tutorial series. We're going to start working on the water jet as well in parallel here. So basically what we're looking at is we're going to be working on the water jet project. So that project is, I ended up buying all that stuff I said in the first video. I can't remember if in that first video I mentioned that I bought all that stuff, but again, I filmed that video about a year and a couple months ago. So since then, I did end up buying a pump and an orifice and the cutting head from AccuStream and the mixing tube. So I bought a ruby orifice cutting head, carbide, tungsten carbide cutting head or mixing tube, and a stainless steel cutting head from AccuStream. So now I have a lot of the components to build this corresponding machine, right? So what I need now is I need some sort of flexible hosing. I need stainless steel to connect to make a manifold, because basically what I did is, let me see if I can find it. Looking on my other screen here. And altogether, you know, I'm a little embarrassed to say how much I paid for it, but I paid about $1,000 for the pump, including shipping. I think it was like $700, and it's only almost like $200 to ship it. So paid about $1,000, and I think it was like, or it might have been oh, here we go. This is actually very similar to mine. I can't remember what website I bought mine off of. I could have swore it was Alibaba, but I cannot find where me and the guy talked that I bought it from. And I talked to the guy for a really, really long time. I talked to him for a couple months, maybe 2 months, before I decided on this particular one. It was all around a pretty good pump. It's a 5-to-1 pump. A 500 to 1 pump, so whatever you put in, theoretically it bumps at 500. Obviously, we talked a little bit about the mechanics. Not all of that energy that you pump into it is converted to compression, to pressure change. Some of that 500 to 1 is changed into temperature, which really doesn't help us at all, right? And then obviously we have some temperature that's dumped from the pump because of this compression. And this is very similar to what I ended up buying. Let's see here. So let's change this to this and that. So let's look at, one second, I gotta sneeze. Okay. Let's look at how long ago exactly that that water jet was. Oh, so yeah, so I uploaded it yesterday, but I filmed it a really, really long time ago. So that first video for the water jet, I filmed, let's see. So I filmed that video, video 1. I filmed that video 6/17/18. So about a year and a month ago. So maybe I did buy it by that time. I didn't actually watch it. I probably should have watched it beforehand. Okay, so here I'm talking about it. Okay, so it was Alibaba.
This actually doesn't use a motor. This actually
so that is the brand.
Compressed air out of a compressor.
That was the brand. It was July was the brand that I did get. It was the 500, so even higher than these. I think I bought it off of their catalog. And then the orifice I went up going with is the 6 thou orifice, so that's about 3 human hairs, ruby orifice, and I think it was a 20 thou mixing tube. So very similar to the Proto Max, which is from Omax. So let's see here. So they have a little bit bigger orifice, and they have a quite a bit bigger So they have also a bigger internal diameter. And they have the same PSI, because I believe it was a 500 to 1. I'll have to look again. Which one? I don't think it was 100 to 1. So it's like 6,000. I think it was like 500 to 1. So yeah, and then something like this. So, I mean, there are... Probably what we're going to do mostly in this video is we're going to look at kind of some designs of different water jets. We're going to start to do some research and look at some different designs of the water jet. But now you know I do have the parts, and I kind of set them aside to look at this possibility of milling. But the reason why milling is kind of fallen apart is that I am struggling to get the time down. So let's go here. So if you look here, the rotary, so this is similar to the time, this is obviously not using a rotary, this is just using one side, but you can see that it will be similar, and this is already 9 hours plus feed, and this is at 20 inches per minute, and this would be most likely on a router, on that metal router that I've been designing, so it's not exactly the best. And so here's one side, the VMC, this is 2 hours and 25 minutes, and the other side is they're 25 minutes. So it's about 3 hours to do one of these. And I need 2 of these, so it's 6 hours plus all the other parts. So I mean, that's not that bad. You're talking maybe 8 hours a machine, but what happens if I get a big influx of these machines and I have to make more? Or let's say I do a Kickstarter again, and I sell like, you know, that let's say 500 of them, or let's say even 250 of them, and then 250, and then I only work 5 days a week. Let's say one per day. You're talking 50. You know, not 5 per day. That's 50 weeks. It's going to take 50 weeks to build that, right? Times 7. That's almost a year. It's going to take me almost a year working almost full time to cut them out. And for the cost, let's see, for the cost that I'm making on it, and that's a lot of wear on the tool, obviously, because the tool is being engaged for a really, really long time. The idea was that the tool was in there for a very short period of time. So if we're talking what did I say? About 7, I'm going to say 8 hours. Well, I'm going to say 7 hours. So let's say 7 hours. So let's see if even the price makes sense. It's about the same that I'm getting paid right now. Which is cool. I mean, most of it's on machine. So I will still be exploring this option. I think the rotary is kind of out at this point, unless I make some sort of discovery. Or I use the VMC with the rotary, but I don't have a long enough table, if you look at the other series. So I'm going to explore back with the water jet, as I've already bought the machine, and I've already paid something similar to the parts that I have that it would cost me to build the VMC. I think the VMC would cost me about $1,500. I think I'm already pretty much there with the water jet. So a couple other things with the water jet. Obviously, if I went with the water jet idea, I'll have to buy a new compressor, because my compressor is way too small to pump out that kind of CFM to get it really to work. So let's see if we can look at some better pictures of the OMAX and see how it's designed on the inside, just to kind of get an idea. Protobex. And then obviously our target is 2 foot by 2 foot, at least to be able to do 2 foot by 2 foot. So that same spot that the mill was going to be is a perfect spot for the water jet. One of the ideas was that if I did build a water jet, the water jet would be below the mill. It would fit below the foot of the mill. 2 foot by 2 foot, as you know, with the Trello, that would just, remember the spot that we have on the floor that most likely this would go is 48 by 28. So I think we have plenty of room there. And we even have plenty of room to get the mill to go around it. Obviously, we'd have to super reinforce the bottom of that table so it doesn't sag, but it could definitely go underneath there. So let's go back and look at, maybe have some pictures. And so they have software, but the software is pretty basic. I mean, there's no tilt head or anything like that. So, and then this is 24 grand, and then it uses a self-driving motor. What is the motor? How big is the motor? It's 30,000 psi, 0.22, mixing 2. Okay. So here's another thing. Like I said, I think I'm gonna have to do up to like 220 mesh. I think the regular is what, 64 mesh or something like that. I'm gonna have to get all familiarized with water jets again because I knew a lot about them until I kind of stopped. Let's see what they've done with it. Oh, this is Roadshow. So yeah, so we can see here that they have the slats that go across, and here's the jet of water coming down. And then obviously some of the, oh, here we go. So here's another option. It's just corrugated plastic, I'm pretty sure. Interesting. But that's the great thing about using water, is that it, so here that's the mixing tubes and orifices. And then here's the cup. Cup is a really good idea. Yeah, the cup is a really good idea. And then after you get started, have the cup like be dragging along your part just to kind of keep the noise down. So as it exits the other side, it's subsonic and it doesn't create so much noise when it leaves the other side. So let's see, maybe some other water jet design. So here we see another slat. This is just a standard head. So here, what I'm thinking that we're going to do in order to try to drop the cost and see if we could do that, is we're going to try to eliminate the pressure control on the high side. So we don't need some sort of 30,000 psi high side pressure. The idea that because we have pneumatic, in order to keep it from draining or coming down and messing up with our like as it pulls out of the cut, as it does its lead out, so it doesn't mess up the cut by engraving some other section. Or most likely what it'll be is it goes to the edge of the cut, stands by for a second, and then we have a blow off valve that'll just release all the pressure, and the pump will just kind of freeze right there. I don't think I talked enough about the pump. Okay, so let's talk a little bit more about what I have inside of the pump. So, the pump again is a 400 to 1. 400. Why is. I'm still trying to figure this out. Why do I have one on my recording? I have two separate channels, but one is a lot lower than the other one. It's very strange. I'll have to figure out why that is, because I was listening to one of my videos and it's very quiet on one side but louder on the other side. It's very strange. So I'll have to figure out why it does that. Anyways, so it's a 500 to 1 pump. It's a dual action, which means that it will compress on the way forward and on the way back. So there are two outlets. Oh, and I think I showed you here. So yeah, it's basically like this. There are two outlets, so this is very similar. So there are two outlets. You have an inlet here, but for example on mine's going to have this kind of deal, but then it's going to have an entryway that you plug in, that you screw on your main fitting here, and then it goes both ways. And then on this side you have an inner manifold where it's the out and it combines and goes out. But this is very similar to what mine looks like. It's super heavy. It's pretty nice. And I think on the Green Engineers I showed it on the Green Engineers channel. So let's see. Oh, there you go. Hey, this is Steven from the Green Engineers, and welcome back to my weekly 2 weeks or less update video, I guess, format. So here you can see this is the pump right here, and here's all the stuff from AccuStream. I got my orifice, I got my stainless steel cutting head, and I got my mixing tube. And so now what I need something to go from here, and then something to tap in there. And then here, and something to tap in. So this is the outside, this is the inside, and I need something to go in there, those two, for water to come in, and for here, the water to come out. And then I need some sort of flexible tubing to go from there to the top of the head, so that the head could move around. Because the main thing that I like the Omax Protomax style, because it doesn't lose any of the volume. Because, for example, in the 3D printer space, you have you have multiple places. You have like the i3 style, Prusa style, and the 3D printer space. Another place you have something similar is in manual mills or VMCs or whatever. You have the bed is actually twice the size as the travel you get out of it. Reason being is that the head is stationary, so you have to get the entire travel all onto one side and then all onto the other side. So the bed has to be twice the size as the travel you get. So if you measured the bed, you'd actually get half the travel if the head was stationary. And in WaterJet, there is no point to have the head stationary because it doesn't have that much cutting forces. But also, I don't want to take up so much space, so I would really like a Parker tube, or some sort of company similar to Parker, have a high pressure 30,000 psi tube come up and connect to this cutting head. And when it connects to the cutting head, it will allow for the size of the bed to be the exact size of travel that I need. So I could have a 25 or a 26, let's say, an extra 2 inches or whatever for the gantries or whatnot, in that particular opening that I have. So let's say it's 20. Let's say it's exactly 28. If you look on the outside, it's exactly 28 by 28. It fits perfectly in that hole, or maybe even wider. 28 by 28. You set it down, and you put it underneath the VMC. You set it down, and then you get nearly that entire volume minus some of the gantry plates and stuff like that. And it doesn't need to be that robust because, again, there's no cutting forces. But there is something, even with the dual action, is that it's pulsing on the the pump is, even though it is dual action, is pulsing. So what I'm worried about also is kind of the kick of the hosing. So the hosing is going to like vibrate as it pumps. So it does still need to be rigid enough that it could take that pulsing. And one of the things that I just got since that video, I just installed it in my room here, which is I have a Tronxy X5SA, which you might be able to hear the fan slightly in the background. It's a Core XY printer that is a 330 by 330 by 400 build volume. And Core XY is one of the fastest kinematics you could possibly get on most machines, and it's super sturdy as far as the stiffness goes. So I'm thinking that if we had something similar to that, actually very similar to how this is built, with obviously the head is going to have to adjust up and down instead of the bed, because the bed is going to be basically a tank of water. And the bed is what's going to be heavy, because the bed is going to have all that stuff on it. Actually, no, I think I'm going to do just like all the other ones do, where you adjust the height of the head with a screw. So very similar to the plasma cutter, which I'll show you here. So yeah. Anyways, it's called Lagmeyer Systems. So here, here's kind of what I'm talking about. So basically they have this adjustable knob right here where you can move this guy up and down. So that's pretty much, and you just place a little focus piece above or below, and then use maybe some different thickness feeler gauges or something to measure it. I might have to CNC that one, but I would really not like, I mean, it doesn't have to travel that fast. It's going to be traveling slower than a plasma cutter. It just has to be sturdy. So I could put a motor there and have it go up and down. But most of the machines on the market do not have the Core XY style kinematic. As you see here, I mean, this is basically the cheapest you could get as far as, I mean, right here it has to be incredibly stable, but only in one spot. And it's cantilevered out, so over here you're going to have the most deflection down, and then it has a motor for each axis. Now, on the other guy, it has a motor for the two motors share different responsibilities, and together they move the machine. And so at any time there's tension on four sides of the motor of the gantry itself. So that makes it incredibly stable and super fast. It's here under my table now, the X5SA. So I think something like that would be really beneficial. So let's go ahead and show you guys what that looks like. Ooh, and this is not it. That's it. I mean, this is the previous version, but it doesn't really matter. So yeah, you kind of see here that they have the serpentine belt go around, and they have another belt here come around. This is the X5S, so this is a previous model. And you can see here it's made out of 2020 extrusion, which I'm thinking for this water jet machine as well. And it keeps everything really, really nice and tight as it travels around. And I think that is really a big bonus. So we have that guy. So let's look at AliExpress and see. Let's see what they have for Core XY. Ooh, this This one's nice. Sorry, kind of tangent here. Yeah, only 200 by 200. I'm basically going to do something like this with mine. Anyways, yeah, I don't think there's going to be a drawing table. That's not a core XY. Wait. Got something here. Cantilever design. But this is kind of a core XY. Sort of, not really. And you can see it uses... So yeah, that's what we're going to use. We're just going to use a... what was it called? Gerbil. Okay, so what about drawing tables? CNC drawing table. It's 40 inches. It's too big. And also it's got a laser attached to it, which is cool, I guess. Oh, wait. Is this Core XY? Oh, this is a Core XY. There we go. Okay, so now we're talking. This saves us a lot of time. I don't know what's there. Is that a laser? Yeah, it's holding the pin. Interesting angle adjust, but it doesn't adjust the other way, so it doesn't really... Oh, you can see the tiny little adjustment there. I like that. So maybe we could do like a servo of some kind here, maybe. Because we just need that little bit of travel, right? We just need like maybe an inch of travel. Because once you get to a certain point, it's not gonna cut anymore. So here, there's a display glitch. I have a thing there. Equipment size. Okay, so there's A4, A3. A4 is engraving area 297. That's too small. 420 by 300. 420. 16 inches, still a little too small. So it's about $140. So I think that's pretty good. So even if we did buy it and then we ended up, yeah, see, you got the aluminum extrusion. Oh, it's got nice corners on it. Even mine doesn't have corners like that. Maybe I should buy some corners like that. Anyways, yeah. Oh, so this is just a drawing robot. So I wonder what this rail's for. Supposed to lock it or something? But I do like this one. So yeah, basically something like this is what we need. Where's the Core XY? Does it have anything similar? Yeah, and I even like this little rail. It doesn't have to be crazy. It just has to hold a few forces, and that's it. No. Okay, so here's a sheet metal. This one looks very promising. It's also an A4. Okay, so basically it's paper size. It looks like it's based on paper size. This is probably more than we need. This is A4. And these look way too far in. It's just a regular one. Yeah. So you get the idea. So basically looking for a machine like that. Core XY. Similar to this, I guess, but it's just got to have the room. Cool. Anyways, you guys get the idea. So that's those are the things that we need. So this guy actually needs very little. We need some sort of valve on the low side to cut the air, and then when it cuts the air, it also evacuates the air. It lets it lets the air go. It just relieves the pressure instantly out the hose. So we need a pressure relief, a computer controlled pressure relief, and a computer controlled valve. Cuts the valve, blows the pressure. Even at the same time, that's okay. And then while it does that, it gives the compressor some time to catch up. Compressor catches up, all that jazz, and then we keep on working. So, and then again, I'm going to also have to buy a compressor. So all in, we're going to probably have at least, this project costs about $2,000 or so, I'm going to say. At least the hose itself might even be a couple $100, maybe $200 even just for the hose. So we'll have to see. I'm going to have to get a hold of Parker and figure that out. Alright, so that's basically it. So thanks for hanging in there for episode 2. I'm going to be still experimenting with all these different ways of manufacturing the shredder, the router, the VMC, and the water jet. I will be continuing all of the videos to their completion. It is obviously I'm going to prioritize the one that is going, the one that's going to be the one that I'm going to go with. Right, so as that interest moves, that's the one I'm going to prioritize. Alright guys, thank you so much for watching, and I'll see you guys in the next video. This has been Steven from Legit Tech Tutorials and the Green Engineers, and I'll see you guys in the next water jet video or any of my other tutorials. Thanks for watching. Take it easy. Peace.